Okay, we are going to solve the next exercise. The exercise is the number 1.22. First, we're going to read it. The acceleration due to gravity on the surface of the moon is 1.62 meter per square seconds. A. What would the mass of the sea climb in active example 1.4 be on the surface of the moon? And B. What would the weight of the sea climb in newtons be on the surface of the moon? Well, as you can see in this exercise, we have to look at what the book did with the example 1.4. So first we're going to review that example and then we're going to continue with our exercise. Example 1.4. The sea climb weighs 14 ounces at sea level. 16 ounces are equal to 1 pound. The acceleration due to gravity at sea level is g equal to 32.2 feet per square seconds. What is the mass of the sea climb in slugs? Okay, what the book is doing right here is that they are transforming, or it is transforming, the ounces to pounds. And once they have, or once the person who did this exercise have the result in pounds, they use it by dividing the gravity on used customary units, and finally they get the final mass. Practice problem. The mass of the sea climb is equal to this one in kilograms. The acceleration due to gravity at sea level is 9.81 meter per square second. What is the weight of the sea climb at sea level in newtons? Well, this is pretty normal, because what we have to do here is just to multiply 0. I'm going to do it on the calculator. 0.397 times 9.81, and here I have the answer that they got here. Why is that? Because as you all know, and I've been explaining this on the previous exercises that we have done, a force is given by a mass multiplied by an acceleration. So this is pretty normal to be the gravity when we are talking about a force, which is the transformation of the weight. Alright, because as you can see, a weight is given principally in newtons, which is a force which is equal to mass multiplied by an acceleration. The mass is usually given by the exercises, or maybe the real life, and the acceleration is is always the gravity. So now that we have checked what the book did with this exercise, now we can continue with our 1.22 exercise. Then I'm going to write down the principal things that we have to take into account. So the gravity on the surface of the moon is equal to 1.62 meters per square seconds. Alright, what would be the mass of the sea climb? So they are asking for a mass on the surface of the moon. Alright, so they are talking about this sea climb. So the example 1.4 tells me that the weight of the sea climb is equal to 14 ounces. And that means that they actually did the transformation of units so this is equal to 0.875 pounds. The mass, well, they are asking the mass, they are not asking the mass in a specific kind of unit, but taking into account what the B section of the exercise is asking me, they want the weight in newtons, so I'm going to use the International System units for the A part of the exercise and the B part of the exercise. So my mass will be in kilograms. Alright, so I gotta change 0.875 pounds and transform those into kilograms, so pound and kilogram, for me to eliminate the pounds. Then what we are going to do here is that we are going to write an equivalence. I've memorized it because I've worked with these kind of exercises a long time ago. So I know that 1 kilogram is equal to 2.205 pounds, and on the calculator I'm going to write down that 0.875 divided by 2.205. So the result is 25 divided by 63 kilograms. I'm going to use this division because I want to use the most amount of numbers after the comma or the point as possible. So now that I have the result in kilograms, I just gotta multiply this result by 1.62. I'm sorry, they are asking for the mass, right? Well, this is something that you have to know here. Then the exercise is trying to trick you. The exercise is trying to like maybe confuse you, because the mass is going to be the same on the Earth, on the Moon, on Mars, on whatever. That doesn't matter. I was a little bit confused because I don't know what they are telling me this on the surface of the Moon, because it's actually the same at every place. At any place you will have the same mass. So this is actually the result for the first part of the exercise. So I'm going to write down the equivalence, which is close to 0.3968 kilograms. Alright, now that I have the A part of the exercise, I'm going to do the B part of the exercise. What would be the weight of the cyclamen-newtons be on the surface of the Moon? Well, it's going to be 25 divided by 65 times 1.62 meter per square seconds. So times 1.62, and that is equal approximately to 0.6428 kilograms times meter per square seconds, and this is the same thing as having 1 newton. So 0.6428 newtons. And that's how, guys, this exercise could be solved.